All right, in this explainer, we're going to tackle one of the most valuable projects out there in machine learning, predicting customer churn. And we're not just talking theory here. We're breaking down a complete production-grade blueprint that real businesses use to save millions.
So why does this matter so much? Well, because a really well-built prediction system can cut customer loss by a solid 10 to 20%. For a huge company, that's not just a small win. It's a massive, massive boost to the bottom line.
For a company the size of AT&T, losing customers isn't just a small leak, it's a billion-dollar problem. We all know it's way cheaper to keep the customers you have than to go find new ones. So the real question is, how do you tackle a problem this big with a process that's reliable and, repeatable?
Well, you solve it with a blueprint, and this is exactly where MLOps, or machine learning operations, comes into play. It's this powerful systematic workflow that's designed to build, deploy, and manage machine learning models reliably and at a huge scale. Okay, let's get into it. So think of this as our roadmap. First, we'll cover how to ingest and prepare just massive amounts of raw customer data. Then, we're going to dive into how we train and tune a model to find those subtle signals of churn. After that, we'll see how to actually deploy that model so it can be used out in the real world. And finally, we'll explore how to monitor and govern it, making sure it stays accurate over time. Let's kick things off with step 1.
First step, turning millions of raw customer records into a smart, predictive model. Honestly, this is where the magic really starts.
Okay, so the whole journey kicks off with data ingestion. And we're talking about absolutely enormous data sets from telecom giants, literally millions of rows of customer info. To handle that kind of volume, you need a seriously powerful tool like Apache Spark, which can chew through all that information super efficiently.
Now, here's the thing. A machine learning model doesn't understand texts like month-to-month contract. It only gets numbers, so we have to translate everything. This whole process is called feature engineering, where we convert all these text categories into numerical values that the model can actually use to find patterns.
We can't just dump all the data into the model. We've got to be smart and select the most predictive features, the signals that actually tell us a customer might be about to leave. We use algorithms like Random Forest for this, and then tools like SHAP. SHAP is amazing. It basically lets us peek inside the model's brain and explains why it's making its decisions. And that explainability? It's absolutely critical for getting the business to trust the model and for meeting compliance rules.
So with our data prepped and our best features picked out, it's time to train the brain of this whole operation. For that, we use an algorithm called XGBoost. It's a real top performer for this kind of problem, and it's famous for its high accuracy in predicting outcomes just like customer churn.
You know how things can get super messy when you're trying out a bunch of different model settings? Well, that's where a tool like MLflow comes in. Think of it like a lab notebook for our entire project. It tracks every single experiment, every parameter, every result, making sure we can always find and reproduce the absolute best performing model. It's a lifesaver.
So how do we grade our model? How do we know it's any good? Well, since only a tiny fraction of customers actually churn, our data is what we call imbalanced. So standard accuracy just won't cut it. Instead, we use very specific metrics. AUCPR, that one measures how well the model can tell the difference between churners and non-churners. Then there's the F1 score, which gives us a nice balance between finding the churners and not making a bunch of false alarms. We're aiming for an F1 score over 0.6 and a lift over 2x, which basically proves our model is at least twice as good as just guessing randomly. Okay, once we have a winning model that hits all our performance targets, we don't just, throw it over the wall to the engineering team. We formally register it in the MLflow model registry. This is a huge step. It gives the model a version, it tracks its entire life cycle, and it stages it for deployment. It's all about crucial governance.
All right, so we've built this really powerful model. Now what? We have to get it out of the lab and into the real world, where it can actually do some good. Let's look at how we turn this model into a live service that can make predictions 24/7.
To make our model usable everywhere, we package it all up into something called a Docker container. This creates this standardized, self-contained little unit that has everything the model needs to run. It's kind of like putting our prediction engine in a box that can be shipped and run anywhere, from my laptop to a massive cloud platform like AWS SageMaker.
Now, for the model to be useful, other applications need to be able to talk to it. So we create what's called an API gateway. An application, say one on your phone, sends customer data to this gateway. Our model inside grabs it, processes it, and sends back a churn probability score. And this all happens in milliseconds. It's the essential bridge between our model and the business.
So the model is live. The job's done, right? Not even close. In fact, one of the most critical phases is just getting started. monitoring its performance out in the wild.
Think about it. The world is not static. Customer behavior changes all the time. Maybe a new competitor pops up, or your company changes its pricing plans. When the live data flowing into our model no longer matches the data it was trained on, we call that data drift. And if you let drift go unchecked, the model's accuracy just tanks, and pretty soon it becomes totally useless.
So to fight back against drift, we set up these automated watchdogs. Tools like Evidently AI are constantly monitoring the live data stream. The second they detect a significant dip in performance, bam, they trigger an alert. And this alert kicks off a process to automatically retrain the model on fresh data, creating a system that is truly self-healing. It's pretty amazing.
Wow. Okay, we've covered the entire workflow, from raw data all the way to a monitored live service. So let's boil all of that down into a quick and easy playbook of best practices. Let's run through this playbook. For scalability, when you're dealing with millions of records, you gotta use a distributed framework like Spark. For data imbalance, where you have very few churners, use techniques like SMODE. It actually creates synthetic examples to help the model learn better. For explanation ability, use SHAP to understand why your model is making its decisions. That's a must for compliance. For monitoring, use tools like Evidently AI to automatically catch data drift. For security, and this is a big one, never hard code your passwords. Use a vault. And finally, for cost, take advantage of cloud features like spot instances to slash your training expenses. This playbook gives you the tools and the tricks for every stage of the project.
And let's not forget the why behind all of this. Following a blueprint like this, it isn't just a cool technical exercise. It directly translates into millions and millions of dollars in saved revenue by proactively keeping customers you would have otherwise just lost.
And here's what's really powerful. This blueprint isn't just for predicting churn. It's a repeatable pattern. You can use it for fraud detection, for demand forecasting, or pretty much any other major business problem you can think of. It's the key to moving beyond one-off projects and toward building truly intelligent systems at scale.
So I'll just leave you with this question. You've just seen the blueprint for solving customer churn. What's a huge problem in your world that's just waiting for a blueprint like this one?